Hello everyone, this is Charlie with Battlers Connection. Today we're here to do a brief overview and sample of the new Combat Gear Multi-C. Basically the C stands for cruiser, or you could use this in a destroyer, so class 1 through 3. This circuit would be more than capable of carrying the ship's needs. As you can see, the size of this circuit is rather small, so it's very light. It is also a power bus, so it carries the power from your battery through your attachments such as your ESC. It also works a pump circuit. There's a built-in pump circuit, and there's also a dual cannon firing circuit on here. So if you're familiar with the Combat Gear pump switch and the Combat Gear dual firing circuit, these two items have been combined onto one circuit to reduce complexity, wiring, etc. And as we know, for a cruiser and destroyer, weight is critical for that particular ship. So being able to compact everything, reduce your wiring, and wiring tends to be heavy on a ship. So for a cruiser and a destroyer, to be able to get rid of wiring weight is a plus. What we'll do is go over a brief overview for what each connector basically does from left to right, and then we'll do a sample of how the circuit works. As you can see here, we have the two servo leads. So basically this is a 2-channel board. The first lead would be your pump. It has a pump circuit built onto it. It's a little bit different than the current board, the pump switch that Combat Gear puts out. Simply the current capacity was reduced from 50 to 30 amps due to the smaller component. It has the output port right next to it. So then it's also labeled pump. So you'd be able to just connect your pump motor directly to the circuit board. On here you have a dual circuit board for your cannons right here for this lead. So aileron or elevator, whichever channel you decide to plug it into. You have the circuit over here, and you can see there's 2 flyback diodes built into the board. There's also 2 associated LEDs with this corresponding connectors. So you have P3 and P4, which correlates to the servo lead in here. So these would be your 2 XT30 connectors that go out to either your Combat Gear test switches, or you can plug directly into your solenoid, and you would no longer need to wire in flyback diodes into your solenoids. The next connector would be a jumper. This jumper is basically to supply battery power coming into this port, this XT60. This is where your battery would come in. It's a through power, so it would be an unregulated power. So by applying the jumper would give you power through these servo leads and power your receiver. So you would no longer need an external power source. So if you're running 5 through 7.2 volts, then you could use that particular jumper. If you're going to run higher voltage, such as 9, 6, 12, or 14, you most likely would have to remove the jumper, because the associated electronics, such as your servo, ESCs, other components may not allow for that kind of voltage. So you would have to reference your manufacturer details for the components that you're going to be plugging into it. But for this demo, we're going to run the circuit on, because we have a live 6 volt pack right here to test the circuits. So as noted, this is an XT60 connector. So the circuit board and its rated power is up to 60 amps continuous. The next connector is also an XT60. It's labeled for ESC. So you would be able to plug your ESC directly in to this port. It could either be brushed or brushless, as this circuit has no function to control what is required. The pump, of course, is for a brushed pump motor, and it's labeled pump, and that would be your output port for the pump. The next XT30 is a out or through power for the test switch. Basically, if you're running the Combat Gear Test switch boards, you'll know that there's a required power input to be able to fire the components without the fire your solenoids without the radio transmitter on. So that would just be through power that you'd wire directly to those boards. And we've already discussed, these are your two Canon firing circuits right here. So we will just do a brief connection of the components and then show you the circuit. You'll notice that with the board like it is right now, it's modular. Each component that we're going to connect to it, this would be an ESC. You notice that for troubleshooting or for changing components, whatever you wish to do, you can do this at the battle. You know, keeping things modular keeps it simple. It allows you to troubleshoot. If you have failures, you can replace the component within minutes. So if you pre-wire up spare components and they're ready to go, you simply just come in and plug it in. You have a new one. Solenoids, as you note, there's no diode in here. We're not going to use the test boards because the test boards, I don't have enough room in this visible window to show you the test boards wired, so we're just going to connect the solenoid direct. And as noted, it already has the flyback diodes built in. And then, of course, the pump. The pump is already pre-wired with a XT60 connector on there, so we can plug that on there. So as you see so far, with things being modular, it's easy if you have a pump motor go bad and you have a spare pump built up. You know, when you're at Nats or you're at a battle, time is of the essence. You know, we only get to do these things once a month or every so often get to battle. So when you travel the long distance, spending time troubleshooting a faulty wire harness or a multitude of connections is tedious and time consuming. Where if you go to a battle and you keep your components modular, you can simply disconnect and plug a new one in, and it's quick and easy. So at this point, we have the pump connected. What we're going to do is turn the circuit on and show you one of its features, the failsafe. The failsafe is basically for if you travel out of range or your ship sinks, the safety feature is the circuit will basically shut down any of the functions. So Canon circuits won't be working, and it'll also shut down the pump. The reason you want to shut down the pump is if you sink and you're sitting on the bottom, you're not sitting there, being underwater wears the brushes out on the motor. So you would want the pump to shut off. So that's one of the nice features, is that the pump will shut off when you've already sunk, because you're not trying to pump out the pond. So anyways, we have a battery here. I have a XT90 on it, so I made a pigtail to drop it down to an XT60, and we will connect this up. Okay, you'll see that the ESC has a no signal light blinking on here. You'll notice on the receiver that there's no LED or link signal on that. None of the red LEDs down here are illuminated to show that none of the circuits are active, but you do see a green LED that came on, and that green LED simply notes that the actual internal components inside this circuit has its power. That's all that green light does, is notes that the circuit is powered. So for troubleshooting, if you see the light, you know that circuit's on. If the circuit's out or the light's out, that means you have no battery power. Pretty simple. All right, so at this point, we're going to turn on the transmitter. You should see an LED on this receiver illuminate red, and that will show that we have link. As you see, now the red LED came on. The LED on here went solid, so that means we now have power to this circuit. Basically, what we'll do is we'll go through and test each of the circuits independently, so you can see that the red LED illuminates. All right, you heard the pump motor come on, and you've seen an LED turn on by the heatsink here. The solenoid, same thing. You can see the LED coming on. That's going to be firing that particular port, which we don't have a solenoid connected to, but we do on the other. You can see the LED illuminate for that side, and you also heard the solenoid connect. And for the ESC, The only thing that's connected to this is the requirement for power to power the ESC. We know it has power because the light illuminated, but we can test the motor. So as you see, this circuit is fully functioning, and it's that simple. And if you note, everything on here is modular. I mean, it's kind of hard with being laid in a pile, but if you imagine if you route your wires in your ship, it would be a much cleaner process. At this point, I'm going to disconnect the power, turn the radio off. So the whole point is, if you're running a ship, to reduce your wiring where you can wire things directly to the component really saves making harnesses and the potential for failure of solder joints, corrosion, all of those natures. These are all XT connectors, and all the connectors are gold plated. When you get your circuit board, it will contain all of the component side connectors, so you'll be able to solder your components on it. The nice thing is being able to keep things modular. Simply being able to take this board and disconnecting it, moving it to a separate ship, is a winner. And if anyone knows me, I like reliability. I like ships to be simple in design. I like things to be modular, because when you're at NATS, you know, time is of the essence. When it's, you know, 5 minutes before the battle, being able to take something and plug it right in and go play is the key to success in the hobby. I hope you found this video informative. If you have any questions, feel free to reach out on any of the combat email forums and contact me, or you can reach me on RC Warship Combat. My screen name's Charlie, or you can send me an email at battlersconnection@gmail.com. Thank you.